Good day, everyone. So, in today's lesson, we'll be looking at the topic temperature and its measurement. At the end of the lesson, we'll be able to know what temperature is by defining it, and we'll be able to know the instrument that is used to measure temperature as well as the types of these instruments. Then, lastly, we're going to be knowing the effects of heat on matter. All right. So, temperature. What's temperature? Temperature, as is commonly defined, is a degree of hotness or coldness of a body. Okay, and it is parameter that is used in meteorology, even in engineering, and medicine and science. Everybody makes use of these parameters called temperature. Okay, so let's begin to talk about the units. Everybody know that temperature is almost everybody knows that temperature unit is degrees Celsius. But that's not the only unit of temperature. Temperature is also measured in Kelvin or in degree Fahrenheit. So basically, temperature has three units. It could be in degrees Celsius, it could be in Kelvin, it could be in degree Fahrenheit. So temperature measures the average kinetic energy of particle in a substance. Okay, so when you want to know the kinetic energy of the particle in a substance, it is the temperature that helps you in knowing that. Now, when the kinetic energy increases, the kinetic energy of the substance in the body, when the kinetic energy increases, definitely the temperature of that body will increase. We are all matter, right? Now, when you discover that your body temperature is increasing, it means that the kinetic energy of the substances in your body has also increased. That is that's the implication. The temperature allows us to measure the average kinetic energy of particles in a substance. So, aside from the definition that it is degree of hotness or coldness, it's actually a measure of the average kinetic energy of a substance. Okay, so that's very, very important. So, these units of temperature that are Kelvin, degrees Celsius to degree Fahrenheit can be converted from one unit to the other. You can convert Kelvin to degree Celsius or degree Celsius to degree Fahrenheit. Very, very simple. So before we talk about the conversion, there's what we call the scale of this unit. Now the scale is the variation of this temperature. We have the smallest value and the highest value. When you are measuring temperature in degrees Celsius, okay, there is this range we call the upper fixed point and the lower fixed point. Okay, now the lower fixed point is the least value that unit can give you. Okay, so what am I saying now? Let me take one of the units as example. Talking about degrees Celsius now. When we talk about degrees Celsius, we are going to be looking at the least value that degree Celsius can measure. That's zero. Okay, zero. So when you're talking about degrees Celsius as a unit for temperature, it means that the lower fixed point is 0 degrees Celsius, while the upper fixed point is 100 degrees Celsius. That's the highest you can measure. Okay. Then, if it is Kelvin, the lower fixed point is 273 Kelvin. Okay, 273, while the upper fixed point is 373 Kelvin. Now, on this scale, there's what we refer to as the absolute temperature scale when we come to Kelvin. What is absolute temperature scale? The absolute temperature scale actually starts from 0 Kelvin or minus 273 degrees Celsius. So when you have to define absolute temperature scale, it is a scale where all the molecular motion ceases. The point where the motion is no longer taking place. We call it absolute temperature scale. And in degrees Celsius, it is taken as minus 273. So minus 273 degrees Celsius if it is taken in degrees Celsius. But if it is in Kelvin, it is taken as 0 Kelvin. So this value is referred to as the absolute temperature scale, the point where the molecular motion ceases. All right. So let's proceed to the part of a simple thermometer. Now, the thermometer generally is an instrument that we use to measure temperature, irrespective of the substance. It is an instrument for measuring temperature. Okay. Now, the simple one look like what you have here. Now, let's talk about the features of a simple thermometer. Now, as you can see in this diagram here, now this place, this is called the bulb. The bulb, okay. The bulb contains the thermometric liquid. This thermometric liquid can be either mercury or alcohol. Okay. Now we also have what we call the capillary tube. It's a narrow tube where liquid rises or fall. This place here, where liquid rises or fall. And then we have what we call the scale. The scale are this line that you are seeing here that help us to measure with ease, whether you are measuring 20 degrees Celsius or so. All right, so that the three major scale, those are the three major parts that you should note in a simple thermometer construction. Now, we mentioned that there is a thermometric liquid in this bulb. This thermometric liquid is not just any liquid. I mentioned that it could be either alcohol or mercury. Even sometimes it could be toluene. Okay. Now, this thermometric liquid, they must have some properties before you can use them. If you are going to use any liquid or thermometric liquid, then they must possess these characteristics. Number one, visibility. Any substance that must be used as thermometric liquid must be visible to the eyes. You must be able to see it without struggling. Okay, it must be visible and easily seen, so that if you want to take your reading, you will not be struggling with it. Another property of thermometric liquid that they must have chemical stability. So it's not that after some time the chemical will now expire. No, it should remain over time. It should be stable over a long period of time without degrading or reacting. Another property of a thermometric liquid is that it must have good thermal expansion. Okay, it must expand uniformly, not that it will expand from 0 to 10, and after a few hours it will be from 0 to 20. The expansion must be uniform. If it is 0 to 10, then it should be 10 to 20, then 20 to 30. It must be uniform. So that is the thermal expansion. The expansion must be uniform. Then another property is that it must have boiling and freezing point. Okay, the boiling and freezing point we are talking about here, okay, must be very, very large, so that it can measure wide range of temperature. And lastly, reproducibility. In this case, it must be consistent in expansion and contraction, okay, for accurate calibration. So these are the properties of thermometric liquid, okay, that we must consider before we can use any substance as thermometric liquid. And we have mentioned that these substances that have been considered over the years are mercury, mercury liquid, and alcohol or something like toluene. But the most commonly used is mercury. Now let us compare this thermometric liquid that I have just mentioned, especially these two, this common one, the alcohol and the mercury. Now let's begin to compare them in terms of temperature range. For alcohol ranges from 115 degrees Celsius to 78 degrees Celsius, while that of mercury is between minus 39 degrees Celsius to 357 degrees Celsius. So from the look here now, you can easily see that in terms of temperature range, that mercury has larger temperature range than that of alcohol, as you see here. Okay, that the temperature range is larger. That of mercury is larger. All right, but if you look at it now, also the freezing point of alcohol is higher than that of mercury. So if you want to measure a very, very small, a very low temperature, alcohol will do it best. But if you want to go for a very high temperature, Mercury will do it better because it had a very high boiling point. Okay. Now, in terms of visibility, which one can you easily see between Mercury and Aqua? Now, Mercury has a color called silver color, so you can easily see silver color. But for Aqua is transparent, except you just add a coloring to it. So, in terms of visibility, Mercury is more visible than Aqua. Then, in terms of thermal expansion, okay, Mercury is consistent and uniform. Okay, so it's consistent in expansion, but that of Aqua, it is 6 times greater than Mercury. So that means Aqua is more consistent than that of Mercury. Okay, so I mean Aqua expand more rather than that of Mercury, but Mercury had a consistent expansion than that of Aqua. Now, in terms of toxicity, how toxic it is it dangerous or not dangerous? Now, Mercury is more toxic, it's harmful, so you have to be careful when you're eating Mercury. But Aqua is less toxic and it is safer. Okay, so it does not harm. Then, in terms of accuracy, Mercury give higher accuracy and than that of Aqua. Response time, so Mercury respond quickly to temperature than Aqua. Aqua does not respond to temperature quickly, okay, unlike that of Mercury. And boiling point, we mentioned that before at the first point. So Mercury have high boiling point, as you can see here. This is 357, but that of Aqua is 78. Okay, so Aqua does not have that of it does not have such high boiling point like that of Mercury. But in terms of freezing point, you could see that Aqua has higher. So they have their advantages and their disadvantages. Now, we have different types of thermometers. All of them are all used for measuring temperature, but their design is what gives them the types. Now, we have the one we call the liquid in glass thermometer. When we say a thermometer is liquid in glass, it means that it has thermometric liquids, okay, in it, like the example we gave earlier. So there is thermometric liquid inside that thermometer. So any thermometer that has thermometric liquid in it is referred to as liquid in glass thermometer. Then we have what we call the constant volume gas thermometer. So in this case, there is no thermometric liquid here. What we have here is gas. So gas is the substance that we use to determine temperature of a substance, okay, using this type of thermometer. So gas is used. So it measures gas pressure. So the pressure of the gas is what we now use to determine the temperature in this constant volume gas thermometer. Then we have the resistant thermometer. In this case, the resistance of the wire of that thermometer is what now gives us the temperature of that substance. Then we have the thermocouple thermometer. The thermocouple thermometer make use of two different metals, which we refer to as dissimilar metals. Okay, and these two different metals generate voltage. The voltage they generate determines the temperature of that substance. So they make use of voltage to measure temperature. We have what we call the clinical thermometer. The clinical thermometer is under the family of liquid in glass thermometer because they also make use of what? Thermometric liquid. But why we differentiate it because it is specifically used to measure the temperature of human beings. Okay, it is used to measure the temperature of human body and it is calibrated in degrees Celsius. Although there are some that are also calibrated in degree Fahrenheit, but the standard is the degree Celsius. Then we have the pyrometer. The pyrometer measures high temperature using thermal radiation. Okay, so the thermal radiation measurement is what gives us the value of the temperature of that substance. And we have the maximum and minimum thermometer. This maximum and minimum thermometer, as well as clinical, are still under the family of liquid in glass because maximum and minimum also make use of make use of thermometric liquid. But in this case, it helps in measuring highest and lowest temperature simultaneously for the day. Okay, it's used by geographers, meteorologists in measuring temperature of the weather. All right, so these are the biggest type of thermometers we have based on the substances that is used in determining the temperature and also the purpose they are made for. Okay, so now going back to temperature scale, we've said that there are 3 units of temperature: Celsius, degree Celsius, degree Fahrenheit, and Kelvin. And we mentioned that we have the absolute temperature scale, which is the point where motion has ceased, motion of the molecule has ceased. Okay, and it is either 0 Kelvin or minus 273 degrees Celsius. Now, you cannot convert from degree Celsius to degree Fahrenheit or from degree Fahrenheit to Kelvin. Any way you want to convert it is very, very simple. We're going to learn that in the course of solving our questions. All right. So let's look at the effect of heat on matter. Of course, when heat is involved, temperature increase. Okay. When you heat a substance, it increases the temperature of that substance. That's very obvious. When you subject a substance to heat, the phase of that substance will change. Okay. If that substance was solid before, it can change to maybe liquid. If you continue to heat it again, change to gas. Again, when you heat a substance, that substance can expand. It can also lead to expansion of a substance. When you heat a substance as well, the substance can change its resistance. In fact, when you heat metals, their resistance increases. When you subject a substance also to heat, they can change the color of that substance. Then it can also lead to thermionic emission. When you subject a substance to heat, at the surface of that substance, electrons can escape or can be liberated from the surface of that substance. That's what we call thermionic emission. So when electrons are emitted out of the surface of a substance due to heat, it is referred to as thermionic emission. Then heat can also lead to chemical change of a substance. When you heat a substance, the chemical characteristics of that substance can also change. All right. So let us look at one or two questions on this temperature and its measurement. Look at this question here. It said a temperature of 20 degrees Celsius is the same as A, 36 degrees Fahrenheit, B, 68 degrees Fahrenheit, C, 11.1 degrees Fahrenheit, D, 43.1 degrees Fahrenheit, E, 25 degrees Fahrenheit. So here, how do we convert degrees Celsius to degree Fahrenheit? That's the point here. So this is very simple to solve. What we need to do is to just draw two vertical lines. Okay, so we draw our two vertical lines. This is the first one, and this is the second one, right? So the first one, since we are dealing with two scale here, which are degrees Celsius, so let's call this first line degrees Celsius, and it's what we are converting into is degree Fahrenheit. Second line is degree Fahrenheit line. Now the next thing to do is to now know. Remember that we said for degree Celsius, the boiling point is 100. So here is 100, while the freezing point is 0. Okay, but for degree Fahrenheit, I didn't mention that, but for degree Fahrenheit, the boiling point is 212, while the freezing point is 32. So this is very important. So you know that the freezing point for degree Fahrenheit is 212, and the boiling point is 212, while the freezing point is 32. And that of degree Celsius is 100 for boiling point and 0. Now, this 20 degrees Celsius is under degrees Celsius, so we put it in between 0 and 100. So that's 20. I didn't put it here because it is not degree Fahrenheit. So we have to convert it to degree Fahrenheit. So that's our unknown. Let's call it our x. Okay, we want to convert 20 degrees Celsius to degree Fahrenheit. So that is very simple. What you need to just do is, let us split our page into 2. Now that will be, you subtract this 0 from 100. Okay, that will be 100. That's the formula. 100 minus 0 divided by, subtract the 0 from 20 as well. That's 20 minus 0. Okay, then equate it with the same process here. Subtract 32 from the 212. Okay, that's 212 minus 32. Okay, now subtract this 32 all over. Subtract 32 from x. That will be x minus 30. That's what we are looking for. That's it. So this is just, the rest is mathematics. So 100 minus 0, that is still 100, over 20 minus 0 is still 20. All right. So equal to 212 minus 32. That should give us 180. Okay, plus 2 minus 2 is 0, and then 11 minus 3 is 8. Okay, remainder 1. So then over x minus 32 is still the same thing because there is no value there yet. So dividing for that, 20 here is 1, 20 in 100 is 5. So we have on the left hand side 5 over 1, okay, to be equal to on the right hand side 180 over x minus 32. All right, now if you cross multiply this now, when you cross multiply, of course you'll be having 5 into bracket x minus 32 close bracket is equal to 1 times 80 is also 1 times 180 is 180. Dividing both sides by 5. Okay, 5 here 1, 5 in 18 is 3, remainder 3 in 30 is 6, right? 6. So we have x minus 32 to be equal to 36. All right, to be equal to 36. Now let's divide it again. 5 in 18 is 3. 5 in 18 is 3. Remainder 3. So that's 36. Now, collecting like terms, we have x now to be equal to 36 plus 32. All right, and this will be giving us 68. Remember that we are converting into degree Fahrenheit. That will be 68 degree Fahrenheit. That's the correct answer. So that's option B. This is 68 degree Fahrenheit. This is F here. F is here. So the correct answer is 68 degree Fahrenheit. All right. Hope we have learned something today from the topic temperature and temperature. Thank you for listening and have a wonderful day. Bye for now.